Okay, welcome to the second video of week 2. Again, this is a function you should recognize. Here's that min function from week 1. So again, you've seen me solve this graphically using Excel Solver, and now I want to do the same thing, but let's analyze this problem using those reports. So I've got everything set up. Should do this though, 1 and a 1. Okay, so everything is now, sorry about that, because I ran the solver earlier, so let me just clean that out. So let me, solve this again. So D4 is good, minimize that by the choice variables D to E3, and then my constraints F6 to F8, and then H6 to H8, okay? Check this box, simplex LP, solve, highlight all 3 reports and hit OK. And of course, here they are, right? So let's just take a look at these. Now, the same thing is going to apply, right? So I don't want to spend as much time. I just want to make sure that you understand how to interpret these for a min problem, right? It's basically the same. The answer report, same thing. The original value was a 54 for my objective function, right? Because I had ones and ones in there, right? 1 and 1 gave me the 54, right? 1 and 1. Okay, my final value for the cost min was 45. The final value for choice variable 1 is 2. Final value for choice variable 2 is 0.5. Constraint 1 used up 3, right? Here they are. And what you can do, make comma format this. Oh, jeez. There we go. Sorry. Right, there's the 6, 5, right? So 3, 4, 6.5. I say that because this is saying 6.5 and I was showing 7. That was just because I didn't have that cell properly formatted. So here are my cell values. The first 2 are binding. Constraint 1 and 2 are binding. They have no slack. Cell constraint 3 is non-binding. We have 3.5 units of slack. Well, sure do, right? 3 equals 3, binding. 4 equals 4, binding. 6.5 is 3.5 units greater than 3, ergo non-binding constraint. Okay, so there you have it. I'm going to jump over the sensitivity, go right to the limits report. Okay, what this is telling you, this is one of the reasons I wanted to do this. So what we see here for this cost minimization function is there are no upper limits, right? You're not going to, you don't want to increase those costs, right? So the upper limit here is NA. And what this is telling me is that the lower limit for my production, this is actually the least production I can have, right? Produce 2 units, the smallest amount of production I can have to minimize my cost, right? So I'm going to produce 2 units of good 1 and a half a unit of good 2, right? And of course, if I want to minimize my cost, I don't want to be producing thousands of units of both, right? Hence the NA. Okay. Sensitivity report. This and I said this before, but this is by far the big one. Okay, so what do we got? Okay, same thing here. Final value 2 and a 0.5. Yeah, 2 and 0.5. So the reduced cost is telling me that if I increased my non-negativity constraint by 1 unit, then nothing would happen to my final values. Okay, fair enough. Even though x2 is at 0.5, if I put a constraint that was 1, I would still be okay. The coefficients are 12 and 42. This is telling me that if my costs for variable 1 increased by $9 or decreased $1.50, holding everything else constant, I would still produce 2 units of variable 1. Holding everything else constant, if the cost per unit for variable 2 increased by $6 or decreased by $18, then I would still produce a half a unit of good 2, right? That's what these allowable increases are telling us. The allowable increases affect the objective coefficient, the objective function coefficients. The reduced cost applies to my final value. Okay, then we have our constraints. Again, these are the final values. So in the solution of our problem, we use 3 units of constraint 1, 4 units of constraint 2, 6.5 units of constraint 3. Here were our right-hand side constraints, right? We had to use at least 3, 4, and 3, okay? Our shadow prices tell us, right, that if we increase a constraint by 1 unit, then what will happen to our cost? Well, this is telling us that if I increase constraint 3 by 1 unit, right, so I go to 4, nothing is going to happen. Nothing, my cost won't change at all. Not a thing. But here, if I increase constraint 2 by 1 unit, then my cost will go up by $9, and I can show that to you. So let's make this a 5. And then solve this. I'm going to go up by 9. Voila! There it is, 54, right? I went from 45 to $54, okay? So that's exactly what this is telling me. And then, of course, the same thing here. If I increase constraint 1 by 1 unit, my cost will go up by 3. And then, of course, these allowable increases and decreases are the same thing. So for this shadow price to remain valid, I can only increase constraint 1 by 1 unit or decrease it by 0.636 units, right? For this for this shadow price to be valid, I can only increase constraint 2 by 1.4 units or decrease it by 1, right? And then, of course, for this shadow price to remain valid, I can increase it by 3.5. Remember this was 6.5, right? If I go back, put this in as a 4, and then solve it again. There, right? That was the 6.5. So I could increase constraint 3 by 3.5 units to get to 6.5, right? And then this would become binding, but my shadow price would be 0. But notice that I can decrease that constraint by an infinite amount. Why? Because 6.5 is already strictly greater than 3. So if I just took 3 down to like a negative a million, big deal. It's not going to affect anything, right? And that's why I'm getting this infinity here. I can decrease that constraint by an infinite amount because it's non-binding. And that's something, I don't know if I said that in the last video. You'll get these infinities only on the non-binding constraints, okay? Generally speaking, for like a maximization problem, right here we have these greater than or equal to constraints. So you're going to get the infinity on the allowable decreases. On the max problems, you have less than or equal to constraints. So if you do have a non-binding constraint, usually you'll have an infinity on the allowable increase. All right? So there, I know I went a little bit faster, but I just didn't want to bore you. The interpretation is basically the same. You just have to think a little bit differently, right? Because now you're minimizing your cost. So again, like this shadow price, this is still the effect on the objective function. So this shadow price is saying, right, that my costs are going to go up, right? In the last video, the shadow price was saying that my profit was going to go up, right? Well, it's the same concept. Just make sure you interpret it properly, all right? So at any rate, that's it for this video. Now I do have one more video for this week, and then we'll be done. All right. So look for video 3 shortly.